Good day guys, today we are doing simultaneous equations. That's our lesson number 12. So what I want you to understand is that simultaneous means two. So these are two equations that are worked at the same time. So I want you to know the concepts that we apply if we are working simultaneous equations. Like these ones, these are simple linear simultaneous equations. Therefore, if we are working these simple linear simultaneous equations, we apply the elimination and substitution method. So what you have to know is that if we work these equations, we apply both the elimination and the substitution method. So let's try to work it out here. So the first thing that we do here is we have to name these equations as equation 1 and equation 2. So we come here and rewrite again 3x plus 4y is equal to 1. So this is your what? Equation 1. Then 4x plus 3y is equal to 6. So this is your equation 2. Now we want to eliminate. If I say we eliminate, we want to totally remove something. So in this case, let's say we want to totally remove x. I'm going to consider the coefficients of x. In this case, the coefficients of x is 3 and 4. I'm going to multiply my top equation by what? By 4, and my bottom equation by what? By that 3. Because I want to eliminate these variables which are x here. In this case, it's going to be 3x plus 4y is equal to 1. Then I'll say times that coefficient, which is what? 4. Then here I'm going to say 4x plus 3y is equal to 6. So it's now times what? Times that coefficient, which is 3. So this means that you're going to multiply the whole equation by 4, the whole equation by 3. We're going to use subtraction if we're eliminating now. So in this case, it's 4 times 3x, that's what? 12x. 4 times 4y, so it's plus 16y is equal to 4 times 1, that's 4. Then 3 times 4x, that's 12x, plus 3 times the 3y, that's 9y is equal to 3 times 6, that's 18. Then I want to eliminate x here. I'm going to use minus because there was no any negative sign there, so I'm going to apply a negative. So it's now 12x minus 12x, that's a 0. I want to write that 0. 16y minus 9y, that's a what? That's a 7y is equal to 4 minus 18, that's a negative 14. I'll divide both sides by what? By 7 there. By 7. Then I'll cancel there. It's now what? Your y. So your y in this case is going to be what? Your y is going to be a negative. So y is equal to negative 2 there. Your y is going to be your negative 2 there. Then we are going to continue now doing the substitution concept. Now if you are substituting, you come here and choose any one of the equations. Then you substitute this variable since you have got what? The answer there. So your y is equal to 2. Your y is equal to 2. We're going to choose any there. So in order for you to understand how to do this, I'm going to take both of these equations and I'm going to substitute one by one. So I'm going to start by 3x plus 4y is equal to 1. I found the value for y to be what? Negative 2, so I'm going to substitute here. It's now 3x plus 4 bracket negative 2 is equal to 1. It's now 3x minus 8 is equal to 1. Then I'll collect my like terms. Is equal to 1 plus 8. 3x is equal to 9. Divide both sides by 3. By 3. So your x is equal to what? 3. Now, let me choose that one again. I'll come here and say 4x plus 3y is equal to 6. 4x plus 3 negative 2 is equal to 6. Then 4x minus this is 3 times 2, that's what? That's a 6 is equal to 6. Then I'll correct my like terms, is equal to 6 plus 6. Then 4x is equal to 12 over 4 both sides. So my x again is equal to what? To 3. So what you have to understand is that if you are choosing, you just choose any of the equations. Now you have solved your equations. Your final answer is like this. X is equal to your 3, comma, y is equal to negative 2. That's it. If you want to prove, I showed you how to prove an equation and determine that it is correct. That's how we solve a simultaneous equation. So this is just a simple linear simultaneous equation. Let me take you to those simultaneous equations that appear from what? From the question paper. Let me try to check it here in, this is June 2015. This is June 2015. I think there's a simultaneous equation there that we can solve. There's a simultaneous equation that we can solve. There's the question. It's June 2015, number 11. Solve the simultaneous equations. Solve the simultaneous equations. Now, these equations, this equation, the way it appears to be like, we are going to only apply the substitution method. I think you can see the way it is structured. We are going to apply the substitution method. Only, we are going to apply the substitution method. Let's just try to work it out. Okay. Instead of rearranging this question and trying to solve it the other way, we are going to say where there is a y, we have to put 5 minus x. So let us try to substitute. In this case, I'm going to take that top question, which I'm going to say 3x minus, instead of putting that y, I'm going to say open bracket, I have to put what? 5 minus x. 5 minus x is the same as y, since the question here says y is equal to, this means y is the same as 5 minus x. So I'm substituting here 5 minus x. This 5 minus x represent what? My y. In that case, my y was what? Was negative. That's why I inserted that negative sign. Is equal to 7. So we are going to find both the values of y and x using that same equation. So in this case, I'm going to have 3x minus 5 plus x is equal to 7. I will then collect my like terms. 3x plus x is equal to 7 plus 5. 4x is equal to 12. Then divide both sides by 4. By 4, I'm going to obtain my 3. So my x is equal to what? 3. It's up to you again now. You choose one equation that you want to use for your substitution. So let's try to take even that one. Y is equal to 5 minus x. Y is equal to 5 minus, instead of for using this x, we are going to take the value of x, that is 3. Y is equal to 2. So that is your answer. Y is equal to 2. So that is our final answer. We are done there. So let me take you to this other form of simultaneous equation, which appears in the form of a fraction. So we are now doing fractional simultaneous equations. There is the question. It's November 2005. That is November 2005. It's paper 1. So let's try to do that fractional equation. You have to know how to simplify an equation that appear in the form of a fraction. Okay, so there is our question. We want to solve that equation first. Once you come across a question, an equation that is in the form of a fraction, first clear off that fraction. So in this case, I want to clear off that fraction. I'm going to come here and say y minus half x is equal to 0. So if I'm clearing that fraction, I'm going to multiply every term by what? By 2, which is my denominator. So it's times 2, times 2, times 2. So these 2's are going to do what? They are going to cancel out here like this. I'm going to cancel this 2 and that 2, right? Now I'm left with 2 times y, that's now 2y minus x is equal to 0 times 2, that's a 0. Then I'll rewrite my equation now. I'll put a line here. So if you're in an exam, maybe these lines we can put them using what? Using a pencil. So now it's now 4y plus 3x is equal to 10. Then 2y minus x is equal to 0. It's up to you the method that you want to use. Some may prefer to use what? The substitution method by making what? This x the subject of the formula. Either way is okay. There are many ways of killing a cat. So in this case, let me use the what? The elimination method. So I would say this is my equation 1, equation 2. I'll come here and rewrite again. So in most cases, it's wise to go doing what? Subdivisions here if you are doing your workings. So I'll come here and say 4y plus 3x is equal to 10. Then 2y minus x is equal to 0. So it's times, I want to eliminate y there. I'm going to say times what? Times 2 here, times 4 here, right? I think you have inserted those. We want to eliminate this now. 8y plus 6x is equal to 20. Then 8y minus 4x is equal to 0. I'm going to separate here. 8y minus 8y, that's a 0. Then take note of this one. Most students tend to forget maybe this negative sign and say 6 minus 4x. You see? So it's 6x minus. So two negatives add. So it's now 6 plus 4x. Just because I said 6 minus 4x. You see? So in this case, it's just what? 10. I'm going to have 10x is equal to 20 minus 0. That's a 20. If I am to divide here, I'm going to obtain what? My x is equal to what? 2. My x is equal to 2. Then I'll substitute there. I'll choose any of the equations. I'll take 4x. I'll take 4x. Is it 4x or it's 4y? Okay, it's 4y plus 3x is equal to 10. Then I want to substitute my x here. It's now 4y plus 3 bracket 2 is equal to 10. 4y plus 6 is equal to 10. I'll then collect my like terms here. Minus 6, 4y is equal to 4. I'll divide both sides by 4. Y is equal to 1. I'm done there. So that is a typical example. Let me take you to this other example of a simultaneous equation that appear in the form of a fraction from November 2002. So there is our question now. It's November 2002. Let's get inside the question paper. There is the question. Solve the simultaneous equations there. Want to clear off that fraction. So using that example of what 2005, you realize that previously we multiplied by 2 everywhere. So in this case, what are we going to use? We're going to use that 4. It's a 4, not a negative 4. What you are supposed to know is that if you are doing fractions, whenever if there is a negative sign, the negative sign goes with the what? With the numerator, not the denominator. The reason being that in maths, a denominator is never negative, and also a denominator is never under a square root sign, right? So let's try to eliminate that denominator. I'm going to come here and say x plus y is equal to negative 1 over 4 times 4 times 4 times 4. These are going to do what? To cancel out there. I now have 4x plus 4y is equal to negative 1. Then, as I said, it's wise for you to underline. Always underline if you work simultaneous equations. After every 2 stages, underline. Then you rewrite your equation now. It's now 4x minus 2y is equal to 5. I'll check that one. 4x plus 4y is equal to -1. These are already eliminated, so it's no longer necessary for you to say you want to eliminate something. They are already eliminated. You just put out a negative sign. 4x minus 4x, that's a 0. Then now minus 2x minus 2y minus 4y is now minus 6y is equal to 5 minus minus is now positive 6 there. Divide by 6, divide by 6. In fact, you divide by -6 here. Yes, by -6, then 6 there, cancel. So your y is equal to -1. You then underline there your answer, then move to the next one. Don't take that one that contains a fraction. It might end up contradicting you. Take that just the easiest, because in this case I'm going to take my 4x. I'm going to take my 4x minus 2y is equal to 5. Then substitute 4x minus 2 bracket -1 is equal to 5. 4x plus 2 is equal to 5. Then I'll come this side. I want to continue with it here. It's now, I want to collect my like terms. It's now 4x is equal to 5 minus 2. Then 4x is equal to 3. Divide both sides by 4. By 4. X is equal to 3/4. That's it. Don't be surprised if you find your answer like that one. It's proper. Then there's this last concept that I want to show you based on these simple linear equations. You find an equation that requires you to rearrange it. Let me give you an example from June 2016 paper 1. Okay, let's continue there. There is our question is June 2016 paper 1. It's June 2016 paper 1. There is our equation. Do you realize that this equation requires you to rearrange it proper, just because there is your y, here is your y. So try to rearrange this equation there. So you're going to say, it's up to you. You want to rearrange this one or that one. It's up to you. The choice is yours. It's up to you on which equation do you wish to rearrange. But in this case, I'm going to choose what? I'm going to choose to rearrange that one. So I'm going to have 6y minus 3x is equal to 1. Then y plus 3x is equal to 13. Now, there your terms are already what? Eliminated. But whenever, if there are terms that are already eliminated, consider their signs. If there is a negative sign, we're going to use what? A positive there. But if both are positive, we're going to do what? We're going to use our negative sign that you were always using there. We're using a negative sign just because both were positive. But now, one of them is what? Is positive. It means we're going to add the whole equation. It's now 6y plus y is equal to 7y minus 3 plus 3, that's a 0. So it's equal to 1 plus 13 is 14. Divide by 7, divide by 7. So my y is equal to 2. I'm done with the y. Then I want to choose the other one. So I'm going to use 6y minus 3x is equal to 1. Then I want to substitute 6 bracket 2 minus 3x is equal to 1. Then 12 minus 3x is equal to 1. I'll then collect my like terms. 1 minus 12, then minus 3x is equal to minus 11. Divide both sides by -3. -3. I'll cancel there. Cancel my negative. So my x is equal to 3 into 11, that's a 3. Remainder 2 over 3. What I know is this. Most of students, they tend to panic if they come across an answer that is a what? That is a mixed number. It's still okay. you're not supposed to panic. If you see that you don't trust your conclusions, you rather prove your answer. Let's try to prove this one. I'm going to use that any one of the equations. Let me say 6y minus 3x is equal to 1. Here we are proving. So this is the proof. This is the proof. We want to prove that are both of our answers correct. So let's try to substitute. It's now 6. Let me use a different ink. It's now 6. Then 2 minus 3 bracket. Let me write this one after I have converted it into a mixed number. It's it's 11 over 3 is equal to 1. It's now 12 minus, I'll then say 3 into 3 into 3. I'm going to have my 11 there. So it's now 12 minus 11 is equal to 1. 12 minus 11 is 1, so it's 1 is equal to 1. I have proven it. It's correct. It's correct. So I'm taking you to the other form of an equation. That is, now we want to create simultaneous equations. We want to create simultaneous equations. Now we want to create simultaneous equations. So we're creating simultaneous equations through factorization. And mostly that form of factorization will be will be the difference of two squares. So let me take you to those types of simultaneous equations. Okay guys, we are now doing simultaneous equations that are being created through factorization. The basic form of factorization that will be used here is the difference between two squares. So in this case, there is the question, given that 4x squared minus 9y squared is equal to 12 and 2x plus 3y is equal to 6, find the value of x and y. So here is the solution. We have to first know that difference of two squares. What is the answer of 4x squared minus 9y squared? As a point to note, you can't answer that question unless you bear something in mind. So upon your solution, you have to know this in your mind, that if you are to factorize 4x squared minus 9y squared, you're going to obtain 2x plus 3y and 2x minus 3y. This is a prerequisite. If you're answering that question, you have to know that that one is to be factorized and in the form of difference between two squares. So now we want to create the other equation. We have got the value of 2x plus 3y. We want to know the value of 2x minus 3y. So we have to create this equation here by just simple division. We're going to say 2x into 4x squared. We'll be dividing here in order for us to do what? To obtain the other term. 2x into 4x squared, that's what? We're going to obtain our 2x there. Then plus 3y into negative 9y, we're going to obtain a negative 3y is equal to 6 into 12, that's what? That's a 2. So here are our simultaneous equations. And what we also have to know is that they will be already eliminated. So it's a matter of inserting your sign. So we want to continue with those equations. I want to separate here. It's now 2x minus 2x, that's a 0. That's a 0 for now. So then 3y minus 3, so that's what? 3 plus 3 is now what? 6y is equal to 6 minus 2, that's a 4. Over 6 over 6. So here it's 2, here is 3. So my y is equal to 2/3. Then I'll do what? I'll substitute here. I'm going to choose n of my equations there. 2x plus 3y is equal to 6. Then it's now 2x plus 3 bracket 2 over 3 close is equal to 6. I'll then say 3 into 3, it's 1. Here I'm left with what? With that 2. It's now 2x plus what? Plus 2. It's now 2x plus 2. Let me do this. It will continue here. It will continue there. It's now 2x plus 2 equals 6. I'll then collect my what? My like terms. 2x is equal to 6 minus 2. 2x is equal to 4. Divide both sides by 2. I'm going to obtain my x is equal to 2. That's it. That's it. And it's still simple, guys. We can still prove that one. We can still prove that one by doing what? By doing our substitutions. Let's try to prove that one by doing our what? Our substitutions there. So this is proof. This is proof. I have a lot of time to do what? To prove this to you. It's now 4x squared minus 9y squared is equal to 12. So let's substitute 4 bracket 2 squared minus 9 bracket 2 over 3 squared is equal to 12. Whenever if you are doing this, we prioritize the what? The index. So it's now 2 squared, that's a what? That's a 4. Then 4 times 4, that's a 16. It's now 16 minus, this side we're going to say 9 bracket, then everything will be affected by what? By that power. We're going to have a 4 over 9 is equal to 12. Then next step, it's 16 minus 9 into 9, that's a 1. I'm left with what? With a 4 is equal to 12. 16 minus 4, that's a 12 is equal to 12. So it's correct. It's 100% correct. That is the answer. It's 100% correct. Then let me take you to past exam question papers. I'll use November 2008 so that you see what I'm teaching you is something that appears in question papers. So there is the question that we are doing, guys. It's a November 2008. That is the example that we are going to do for now. See the question. Factorize. Firstly, I think you will be given the guideline there, so you automatically see what you are supposed to do. Firstly, it says factorize x squared minus y squared. That is a difference of two squares. Your answer is x plus y and x minus y. Then below there is the question. Given that x minus y is equal to 4 and x squared minus y squared is equal to 20, find the value of x and the value of y. Meaning that we have to apply that concept which I was showing you on this previous example. So there is the format of doing our solution. That one is a prerequisite. You have to know that before you attempt anything, you have to know that. So it's a prerequisite. So we're going to apply our concept. We're going to divide x into x squared, that's an x. Negative y into negative y squared, that's a positive y, is equal to 4 into 20, that's what? That's a 5. So here are our what? Our proper simultaneous equations. Here are our proper simultaneous equations. There, our proper simultaneous equations, we now have them. So we're going to do what? As I said, they will already have eliminated themselves. So it's now minus there. It's now x minus x, that's a 0. Then in minus y is negative 2y is equal to 4 minus 5, that's a negative 1. I'll divide both sides by negative 2. Negative 2. Negative. So y is equal to what? Half. Y is equal to half. I'm going to take any of my equations. In this case, I'm going to use x minus y is equal to 4. Then I'll substitute x minus half is equal to 4. then x is equal to 4 plus half. My final answer, x is equal to 4.5. That is my final answer. I'll be done there. I don't think there's anything more based on our fractions, on our simultaneous equations. I think I've done justice there. I've shown you all the forms of simultaneous equations that you can meet. Above all, practice those simultaneous equations that appear in the form of what? Of fractions and these types of simultaneous equations. I think I can say we're done here. We're going to meet on our next lesson where we will be doing what's the next lesson? We're going to be doing our we're going to be doing our inequalities. We're going to do all forms of inequalities, right? So that's our next lesson. Thank you for your time, guys. Make sure you keep on practicing a lot so that you improve and excel in your examinations. I'm here to help you. Thank you for your time, guys.